we're going to do our last lesson of this unit. This is the unit on rigid motions. Our last topic of this unit is transformational symmetry. This is lesson 312. By the end of class, you should be able to identify if a figure has line, point, or rotational symmetry. So let's first just define symmetry. Symmetry is a figure. We say that a figure has symmetry if there's a transformation that maps the figure onto itself. So has symmetry when a transformation maps the figure onto itself. So there are different types of symmetry. One type of symmetry is called line symmetry. So line symmetry is when there is a line that divides the figure into two congruent halves. So I have an example over here. We have a heart and there is a line of symmetry drawn. You can also call that a line of reflection. Notice that the heart maps onto itself over that line of reflection. So let's tell whether each figure has line symmetry, and if so, we're going to draw all the lines of symmetry. So this trapezoid has line symmetry because I can draw a line through this figure and it maps onto itself. This parallelogram does not have any lines of symmetry. I can't draw a line anywhere and have it map onto itself. This star has line symmetry, so I could draw a line through here and it would map onto itself. I could also draw a line of symmetry here, or here, or here, finally here. So this star has 5 lines of symmetry. Please pause this video and try the U-try. All right, here are the answers for your U-try. You should have had 2 lines of symmetry, 1 line of symmetry, and 1 line of symmetry. So on this U-try, there was 1 line of symmetry horizontally through the capital letter B. What I'd like you to do is pause this video again, and with your partner, think of as many capital letters in the alphabet that you can that have line symmetry. Please draw the lines of symmetry through the letters. Please pause the video now and work with your partner. Okay, lines of symmetry that you and your partner should have gotten. Capital A, B, C, D, E, H, I, K, M, O, T, U, V, W, and X all have lines of symmetry, and depending on how you draw a Y, could also have line symmetry. Line symmetry is not the only type of symmetry. We also have point symmetry. Point symmetry means that if you take a point and reflect it through a point, that it maps onto itself. So I can take any one of these points and reflect it through a point and it maps onto itself. So point symmetry is when you reflect through a point and the figure maps onto itself. What else we could say, since it's a point reflection or point symmetry, is if the figure can be rotated 180 degrees and looks the same, it has point symmetry. So if I take this figure here and rotate it 180 degrees, if it looks the same, then it has point symmetry. So let's look at some other examples. Tell whether each of the following has point symmetry. So if I take this figure and rotate it 180 degrees, if it looks exactly the same, then it has point symmetry. So yes, this card has point symmetry. If I look at example B, if I rotate it 180 degrees, I want you to notice that the sun is on the left-hand side, and over here it's on the right-hand side. So this is not an example of point symmetry. It does, however, have line symmetry. What I'd like you to do, please, is pause this video and try these three, deciding if it has point symmetry. Okay, now that you're back, let's answer these questions. Tell whether each of the following has point symmetry. Yes, this has point symmetry. If you rotate it 180 degrees, the figure maps on top of itself. It looks the same. This one did not look the same. If I rotated it 180 degrees, this point should be up on the top. And the letter H, yes, has point symmetry. If you rotate H 180 degrees, it still looks like the capital letter H. On this you try, the capital letter H had point symmetry. What I'd like you to do is pause this video, and with your partner, think of as many capital letters in the alphabet you can that have point symmetry. Pause the video now, and with your partner, write down as many capital letters that have point symmetry. Okay, now that you're back, you and your partner can check your work. Capital letter I looks the same upside down. O looks the same. S, X, Z, N, H, all are examples of letters that have point symmetry, meaning if you turn them upside down, they look like the exact same letter. Our last type of symmetry that we're going to talk about today, on the next page, is called rotational symmetry. Rotational symmetry means that if you rotate the figure around a point, it would map on top of itself. Rotate figure around a point. It maps onto itself. So here I have a flower looking figure, and I'm going to put a transparency down on top of it so you can take a look. So rotational symmetry says if I turn this flower a certain number of degrees, it will land on top of itself, and so it does. And I can actually turn this figure a few times to have it map on top of itself. The number of times that I can turn it to have it map on top of itself is called the order of rotation. So down here for order of rotation, we're going to say the number of times you can rotate to map onto itself. So this figure we determined, yes, had rotational symmetry because you could turn it and have it map onto itself. And how many times can we turn it? 1, 2, 3, 4, 5, 6. That means the order of rotation is 6. If I want to find the angle of rotational symmetry, I know that all the way around is 360 degrees. If I divide that by my order of rotation, that tells me that each 60-degree rotation Each 60-degree rotation will have symmetry. It'll map onto itself. So once again, I took my 360 all the way around, I divided it by my order of rotation, and each 60 degrees maps on top of itself. Let's take a look at the next one. Here I have a transparency. Does this figure have rotational symmetry? Can I turn this and have it map onto itself? It does not look like I can. But it still has an order of rotation. I can rotate it at one time all the way around 360 degrees and have it look the same. But that does not mean it has rotational symmetry, because every figure can be rotated 360 degrees to look the same. So it does not have rotational symmetry. Let's look at an example. Tell whether each figure has rotational symmetry. If so, we're going to give the angle of rotational symmetry and the order. So can I rotate this around a point and have it look exactly the same? Yes, I can. I can rotate it 2 times, which means my rotational symmetry is 180 degrees. For number 2, for B, if I rotate it, I can't ever have the M map onto itself except for 360 degrees. And for the last one, I can rotate this and have it look exactly the same. Yes, the order would be 1, 2, 3, 4, 5, 6. So 360 divided by 6 means I have a rotational symmetry of 60 degrees. I would like you to pause this video and try these 3 problems on your own, please. Okay, now that you're back, the answer here is yes, this has rotational symmetry. The order is 3. 1, 2, 3. So 360 divided by 3 gives me 120 degree rotational symmetry. On to B, yes, this has rotational symmetry. I can rotate it twice, upside down and right side up, which means it has 180 degree rotational symmetry. And the last one, I cannot turn this at all and have it look the same. This does not have any rotational symmetry. If you need to go back and look at any part of this video, you can. What I'd like you to do now is work on the check for understanding. You're given these figures. You are going to sketch the lines of symmetry on the objects below. How many lines of symmetry did you draw? Decide if it has rotational symmetry. If yes, state the order and the angle, and then decide if it has point symmetry. When you're finished, you can check your work with your partner, and then you can work on your homework, or you can work on the extra review sheet that you picked up when you walked in the door. Your homework answers also were provided when you walked in the door. Please make sure you're studying for your exam, which is tomorrow. And also, please make sure that if you have questions, you stay after school. I will still be after school today, even though I'm not in class. All right, guys, thanks so much. Bye-bye.